Now in part C, we're told that we have another line L2 that is parallel to the vector I plus k, and it crosses the line L1 at a point C. So I would always suggest you draw a diagram to bring this problem alive. So this is my sketch so far, and let's imagine then that we have our line L2. I'll draw that in. I'll choose another color for that line. Let's have a red line here. So imagine that we've got our line going through the origin, okay, and let's suppose it's that line there, L2. We're told that this crosses over the line L1 at a point C, so I'll say that's the point C. And we're also told that this line L2 is going in the direction of the vector I plus k. So what I'll do is I'll draw a vector going in that direction, okay, I plus k. There you go. I plus k is a column vector. I could have written as 1, 0, 1 if you like. Alright. Now we've got to find in part C then the angle, the acute angle between the lines L1 and L2. So how am I going to do that? Well, this is the angle, say, up here. Let me call it theta. Now when you're finding an angle between two vectors, you have to use the scalar product. The formula cos theta, let's just write it down here, cos theta equals a dot b all over the magnitude of the vectors a and b. But the question is, what are my vectors a and b going to be? Well, those two vectors are going to be the vector ab and the vector I plus k. Let me just demonstrate. Because if I take the vector AB, let's see if we can move it up to there. If I take this one and move it to there, hopefully you can see that the angle that we require is the angle between the vector AB and the vector I plus k. I'll just move those vectors back because it is becoming a little cluttered there in that area. Alright, so we'll just move that back to there. So the angle theta is then the angle between the vector AB and the vector I plus k. So it's those vectors that I'm going to use as my A and B. So if I was to say then let A equal the vector, let's say 1 minus 2, 2, or I could write it as in i's, j's and k's. That would be just simply I minus 2j plus 2k. And if I let the vector b be equal to the vector I plus k, then we can start on working out what theta is. So we have that cos theta is equal to A dotted with B, and hopefully you remember that to dot two vectors together, what you do is you multiply the I components together and add it to the product of the j components, and then add it to the product of the k components. So in other words, we have a 1 here and a 1 here, so that would be 1 times 1. Then we add it to the product of the j components, so that's negative 2 multiplied by the j component here, which is 0. Then add the k component here, 2, multiplied by the k component here, 1. And then that's all divided by the magnitude of A multiplied by the magnitude of B. So to find the magnitude of vector, it's the square root then of the sum of the squares of the components. So that would be 1 squared plus, you don't need to write the minus in, just the 2 will do, so that's 2 squared plus the 2 squared here. So we have that. and then we multiply that result by the square root then of the b value squared. So that would be 1 squared. We have plus no j's, so I'll leave that out, and then we just have the k component there, that's squared. So working this out, you should find the top comes to 3, and on the bottom you've got the square root of 9 here, which is 3, and here you have root 2. The 3's cancel, so you have 1 over root 2. This is a well-known result, the inverse cos of 1 over root 2, but if you don't know it, you can do it on a calculator, and you find that it comes out to be 45 degrees. So there you have the acute angle theta between the lines L1 and L2. And that brings us to the end then of part C.